Hello, everyone. Welcome to our webinar today, to this Applanix webinar on GNSS augmentation solutions for UAV survey and mapping. We're going to take a look at correction solutions that we offer to basically correct UAV data, getting that data down from, say, for example, a meter of accuracy down to a couple of centimeters of accuracy. So that's really what our focus is on the webinar today. And just want to introduce the team that we have. My name is Brad Schmidt. I'm the Global UAV Sales Manager here at Applanix, and I'm joined today by Kurt Bioletti, who's from our product support department, and he's a product support analyst, and he'll be helping us out with some questions at the end of the presentation. Sanjeev Trehan is with us, the Director of BD and Sales at Trimble India. So we have our Indian representation here. Naush Lada, our Sales and Channel Development Manager, who's working quite a bit in India with Sanjeev and basically presenting and representing the technology that we have in the Indian market along with our partners there. So the format for our presentation today is a 20-minute presentation. Now, we've actually pre-recorded the presentation, so even though I'm live right now, I'm going to be starting a broadcast here, or a pre-recorded broadcast once we get through some of the introductory sections here. And then what we'll have is probably about 5-10 minutes worth of questions at the end. We will certainly make this recording available to you. And I want to encourage you that if you have any questions throughout the presentation, please feel free to enter those in the questions box, and we'll get to them at the end of the presentation. So I do want to thank our partners in India, the Drone Federation of India, who is helping us sponsor this through promotion of this event in India. So we're very grateful for their participation. This is the second of the webinars that we've done through DFI. The first one was a webinar on why use Applanix direct georeferencing for UAV survey and mapping. That is available today in our webinar center if you wanted to go back and take a look at that one. This one really this particular webinar here really kind of follows on what we discussed in the first webinar. However, at the same time, it also is kind of standalone and kind of presents a segment of the technology that we have in our UAV mapping, survey and mapping portfolio at Applanix. So what we're going to do is, as I say, we're going to go to the recorded session now. So we're going to play that, and then we'll come back live and we'll do a bit of a follow-up, and we'll take the questions, and then we'll do a wrap-up after that. Now, let me just see if I can get this started here for you. Okay, our agenda for today is we'll talk a little bit about who we are. For those who may be joining for the first time, we'll give you a bit of a background into who Applanix is. And then we're going to get right into it, right into the augmentation solution. So we're going to talk about physical base stations. We're going to talk about using virtual reference stations. And we're also going to talk about something that Trimble has set up globally called Trimble PPRTX, which again is a non-physical, or there's no physical base station involved in using PPRTX. And we're going to talk about what that is and how that works and why you might want to use it. And we're also going to take a look then at the data processing solutions. Obviously, you're collecting data on your UAV platform. You're capturing your GNSS or positional data with your GNSS and your integrated IMU on your UAV platform. The IMU captures the orientation data. You take that along with your correction information. You process that through a piece of software, which Kurt's going to talk about later on. And you get your final products coming out of that, either an EO file, exterior orientation file, or we can actually generate a LAS file as well, which can then be used in other applications. So let's just turn right now to Applanix a little bit, and a little bit about the company. So Applanix was formed as a spin-off from Honeywell in 1991. We're basically specialist in inertial navigation systems and integrating that technology with GNSS, which actually made for the marriage with Trimble in 2003. We were acquired by Trimble in 2003. So Trimble is a leader in GNSS technology. Applanix is a leader in INS, or inertial navigation system technology. Integrating that technology then for the purposes of direct georeferencing is really what we're all about. And a lot of the technology we're going to talk about today, or at least the supporting technology on the GNSS IMU side, has been well proven in our manned aerial products over many, many years. These products were just refactored for the UAV industry, specifically to support the surveying and mapping aspects of the UAV industry. So, we're not into videography or anything like that. We are specifically into surveying and mapping and precision positioning of data on the ground. Just a little bit more about Applanix. We do have a land division that where we have mobile mapping solutions and autonomy solutions. We have a marine mapping division, as well as our airborne division, which is composed of our manned airborne segment and an unmanned segment. And Kurt, if you could basically just take us through the what and why of GNSS augmentation. Are you able to hear me, Kurt?
Yeah, I can hear you, and thank you very much for the introduction.
Awesome.
So yeah, diving right directly into things, when we start to try to talk about direct georeferencing and how we can get an optimal solution from that, we need to really start talking about GNSS augmentation and what that really means from a mapping and survey application here. So the GNSS augmentation is utilizing additional measurements, whether they be from independent ground-based measurements from a dedicated base station or corrections from certain modeling to minimize and characterize the errors in the GNSS observations. This is going to be critical to get those real-world positioning down to that centimeter level as talked about. And then we can apply our direct georeferencing from there, produce final products. So some of the ways that we typically utilize this, as previously mentioned, are single base station, whether this be from a dedicated base station that you put up or a CORS network. This is a very common and widely accepted and utilized method utilizing differential GNSS. Now, we are also going to talk about really quickly the post-processing VRS using Applanix SmartBase, and then finally wrap up with post-processed Centerpoint RTX, which is kind of Trimble's new proprietary corrections there. So going directly into this, with the single base stations, what we're really trying to do is apply that differential GNSS, which is a very common GNSS surveying technique, where we're going to be utilizing a survey grade high accuracy, multi-frequency, multi-constellational reference station to apply a differential GNSS and completely remove a lot of the common errors that are associated with GNSS observations. This is typically done either using a dedicated receiver placed on each mission or a continuously operating reference station, such as a CORS downloaded from the web, or even a base station provided from a network provider, such as CanNet or SmartNet or something similar to that. Going a little bit more into how this is actually physically working. If you are setting up your own base station, you're going to be setting up again, a survey grade reference station in your project or near your project area. You're going to want to be collecting at least that 30 minutes of survey data so that you can start to get a really accurate post-processed coordinate for that setup base station if it is not set up over its own ground control point or set up as a core station. And then you're going to need to have that proper overlap between the rover and the base station to get a proper differential GNSS correction applied. So going into a little bit more about how Applanix has introduced this, I'm going to talk a little bit about Smart Target, which is the next slide. When it comes through, here we go. Smart Target, which is what Trimble has introduced to kind of address this, provides both a survey grade GNSS receiver along with a target that you can be placed into your project area. You can then correct your GNSS observations with this and then utilize this as a quality control point. The coordinates can be automatically surveyed through POSPAC utilizing the RTX base station survey, and provides a really nice tie-in for everything and makes it a very versatile tool to be utilized in the field. Alternatively, commonly used are the core stations. These are going to be your continuously operating reference stations that are found throughout the world. Here you have to be a little bit more careful making sure that the network or your project area is close to one of these, ideally within the 30-kilometer baseline length. Additionally, another limitation that's commonly applied is that we have to wait 24 hours as we look for the 24-hour Rhinex file provided from these core stations. So it does have some limitations, but then you don't need to properly set up your own base station, and it provides you again, those really good accuracies. So this is going to be perfect for your small area locations and your mapping projects that you're not doing such things as corridor mapping. You are going to be limited in your baseline length, so you need to plan ahead and make sure that everything is collected properly. But in doing so, you can obtain those centimeter accuracy levels. All in all, it does really well, and it is very commonly used in UAV applications. So talking next about a VRS, which is trying to eliminate some of the limitations that are found with single base processing. There's two Applanix smart bases that I'm going to talk about real quick. There is a full version, which is through POSPAC, which will have functionality for creating a rover or like a virtual reference station that moves with the rover, trying to minimize that baseline length, opposed to an online version. That has limited functionality where it creates a static virtual reference station close to your project area. But both are very, very acceptable and utilized quite commonly in UAV applications where we can start to try to minimize those baseline lengths based on a network of stations. So we're utilizing this network of stations to create a virtual reference station. This is typically can be really nicely done either with your core stations, or if you have any private companies that you subscribe to, and you can supplement those. Additionally, kind of going on to that, talking a little bit about exactly how it works, we're utilizing Trimble's VRS technology to take that network of stations and obtain a fixed ambiguity solution. Typically, this is done by generating spatially ionospheric models and correcting for geometric errors for both the base and the rover location. This will provide a very nice optimal VRS that follows the rover and can then, again, minimize those baseline lengths. So this is going to be really great for your larger areas or your corridor mapping, because you get that centimeter level accuracy without that baseline length dependency, because the baseline length is following along with the rover. Limitations mainly being that you need to make sure that your area has proper coverage, aka the base stations surround your area so that we can do proper interpolation techniques, and that you must wait 24 hours for the base stations to become available, typically 24 hours. Again, now trying to address those types of limitations, Trimble has really been focusing a lot of research and development into their Centerport RTX technology. So this is a little bit of about what RTX is. So this is going to be your global real-time GNSS correction technology that Trimble has created. This is going to be using their dedicated network stations throughout the world to create that track most of the constellations, including GPS, GLONASS, Beidou, QZSS, and Galileo. And then utilizing this information, we can start to create essentially compute precise ephemeris information in near real time. Again, this will also start to talk about and correct for the atmospheric delay models. It is certified with a integrity layer just to ensure correctness and ensure safety for applications such as automotive with the self-driving vehicles. The great part of it is there's no need for setting up your dedicated base stations yourself, and it is the accuracy is approaching what you can obtain from an RTK solution. Now, since this isn't utilizing directly differential GNSS, so we don't immediately eliminate the errors, we have to model these errors. So this takes some convergence times that you have to start to look at, and that's all based on what models are being utilized, so what ionospheric models. So if you're in a region that has standard ionospheric models, then typically our convergence times are around 15 minutes before we're going to get full accuracy. And then if you're in a fast convergence region where we have a regional ionospheric model, opposed to just the global one, we're going to get about a 5 or less than 5 minutes of a convergence time. Now, here's just a quick plot to show examples here. The little blue dots are going to be the GNSS observations, and you'll see in the left example where we're utilizing the global model. At the beginning, the dots are all over the place. We got our green line, which is indicating the mean, and it looks like it's getting under the 5 centimeter mark at roughly 4.7 minutes. We got our confidence level at 68%, which is going to be the pink line. Again, it is going under the 5 centimeter level at 3.4 minutes. Then looking at the confidence level of 90, again, that's hitting at 6 minutes, and then by 6.6 minutes, we have a 95% confidence interval that it's under the 5 centimeter error. Now, and that's specifically for horizontal performance. Now, looking at a RTX fast region where we're utilizing a denser network of stations to get a very region-specific model, we can see that everything's converging extremely fast with the mean and both the 68 and the 90% confidence interval converging at the 0.7 minutes, and then finally at the 95 confidence interval at the 8-minute interval. Start talking a little bit about where these regions are fast. You'll see that a lot of North America is starting to get covered here with all of the states completely covered, bleeding up into Canada and the high populated areas such as Toronto and into Quebec, and then over through some of the prairie provinces. Starting to get really good coverage here, and it is constantly expanding the network. Now, if you start looking at Europe, you'll see that they have a very dense, all of Europe's covered, plus we're starting to bleed into some additional countries with that RTX fast regions. So when you start post-processing utilizing RTX, which we're going to just abbreviate down to PPRTX, and both in POSPAC or POSPAC UAV. The workflow is pretty straightforward and simple. You get your trajectory information, you upload it to the RTX servers. The RTX servers then determine the corrections for that area, provide those corrections back to you, which we then feed into the GNSS processor along with the raw observables, so we can really correct that GNSS data. And then all this information is fed into the inertial processor to blend in with the IMU and provide that highly accurate position and orientation information. Going from there, again, basic uses here, we're looking at large areas or quarter mapping because you're not worried about a baseline length, you're not worried about too much there, and it's really good for remote areas where there is very minimal baseline or base stations, such as a lot of places in northern Canada or even just throughout the US. Gets you that centimeter level accuracy without needing to worry about where you're flying or where you're located. Main limitation though here being the convergence times. Because we're trying to ensure convergence times in both a forward and a reverse direction, the entire project must be longer than the convergence time. So for instance, 30 minutes, because there's a 15 minutes convergence time in the forward direction and a 15-minute convergence time in the backwards direction, we're going to want a 30-minute convergence time in standard regions so that we can get a convergence-free zone for the entire collection. This isn't too bad, but it's something you need to keep in mind. In fast regions, you just need that 10 minutes of the flight completely in 10 minutes. Now in a UAV application, it's very common for these to get these times without burning battery power. You can do some static on the ground using a additional power source and then take off. Going a little bit now talking about post-processing with POSPAC UAV. So POSPAC UAVs are a post-processing suite that's been designed and tailored directly for UAV applications. You're going to be feeding in your raw data, specifically GNSS, inertial, or additional sensor data such as a DMI, and then whatever base station data if you are doing something such as a VRS network or a dedicated base station. And then we can go ahead and apply our common filter and our forward, reverse, and smoothing to obtain a smooth best estimate of trajectory. This is something that's very commonly used for LiDAR applications. Additionally, as another additional input, we can also take in the raw LiDAR data and start to adjust the trajectory and output a LAS file. So additionally, looking from a camera perspective, exterior orientation parameters and exterior orientation are extremely important just so you can start to apply that direct georeferencing. So again, that's a very common output that POSPAC can start to play with. Nice and modular also, so in the case that you need to make a custom export for whatever application that you require, specifically referring to the position and orientation information, it's more than happy to do so. Main benefits over something like AT with ground control stations to provide that precise mapping and survey grade solution. In POSPAC, you get to really save time because you're going to be applying that direct georeferencing. You can also start to really dive into the data and understand what's happening and where any errors are coming from, and try to really find out where your optimal sources are. We are also going to talk a little bit real quickly about something relatively new here, which is the UAV cloud. POSPAC UAV cloud is something that we've just introduced, where POSPAC will apply or provide an API for OEM users to build into their own software. This can be built on a pay-as-you-go type plan, where the hardware has become a little bit cheaper so that you can pay as you get your projects in. And when you get a project in, you go ahead and upload the data. It post-processes in the cloud, provides you your end results, and then you can go ahead and supplement in that regard. Now, again, it provides an alternative licensing option, as opposed to just paying a large amount upfront to have the post-processing software in full functionality, by giving that different options to the users.
Okay, thanks very much, Kurt. And certainly, if you have questions regarding Kurt's presentation, just enter them into the chat box, and then we'll address them in just a moment or two. Wrap things up here before we move on to questions. So we did take a look today at augmentation systems or augmentation solutions for survey and mapping missions, and we took a look at 3 different solutions that are available: single base station, virtual reference station working with CORS network, as well as the POSPAC PPRTX solution from Trimble. And then we also had a look at our post-processing software, which is called POSPAC UAV. We also do have another post-processing solution called POSPAC MMS, but that basically supports processing from all of our suite of products, right from the marine suite to land and autonomy and mobility, as well as all of the aerial processing products that we provide. Okay, everyone, hopefully you can hear me okay. So that was the presentation that we had recorded for you. And so what I want to do now is just jump into some observations about using these correction solutions within the India market. So working with the Drone Federation of India, we have kind of targeted this particular presentation to the India market. So I do want to just take a moment and talk about how these particular correction solutions are relevant to the India market. So the first thing is that if we take a look at our smart target, which is pictured there in the lower right-hand corner, this is really suitable for, well, most projects you'll find that this is suitable for. So it contains a target that you can identify in the imagery. You can see the blue and yellow target presented there along with a GNSS receiver inside that target. So we use this to collect a ground control point or a checkpoint so that we can verify the results of our data that have been collected. So if you're just kind of flying local areas, then basically this is a great solution. And this smart target doesn't cost a lot of money. You can simply toss it into your project area. You can turn it on using a smartphone, very nice application, and it works very, very well. And it helps us to get that data from, say, for example, a meter inaccuracy down to a couple of centimeters. So this solution certainly works very well. Right now, we don't have the access to the CORS network in India, although it's something we'd certainly like to introduce in the future. So the Applanix Smart Base is not yet available in India. The PPRTX service certainly is the standard PPRTX service that Kurt talked about, is available in the India market. One of the things that you need to keep in mind with that, and Kurt mentioned this as well, is that in standard regions like India, where we don't have fast RTX yet, it takes about 30 minutes to initialize or gain that convergence. So, and as Kurt had also pointed out, kind of the way around that is to basically have your UAV turned on the ground, and it can start basically working on the convergence of that data coming in and getting it all properly initialized, and then you can switch to your main UAV batteries for your flight. So even though this takes a little bit of time right now in standard regions, it's certainly faster than if you had to go out and set a layout of ground control points to do your work. So, and that is available on a subscription basis. And on that note, basically, we have just introduced something called POSPAC PPRTX for UAV. And really what this is for short flight UAV, so anything less than 30 minutes, we have a subscription service for that specifically for UAVs. And the real difference there between just the regular PPRTX service and PPRTX for UAV is that for these smaller areas and smaller flight areas, this provides very, very attractive pricing for your costs in terms of running your missions, etc. So it's really just, it has the same great technology and capabilities as PPRTX, but PPRTX for UAV is just less expensive if you're flying these shorter project missions. A couple of things that I do want to just mention before I open it up to any questions. And please, again, if you have questions, enter them in the question box, and we will basically address those questions. Okay, so I did want to mention something about the Centerport RTX. So basically, that standard RTX service we talked about, Centerpoint RTX, works with all of our board sets at Trimble. So it's not just the survey and mapping board sets that we're kind of really referencing in today's presentation, but it's also all the different types of board sets that we have. So not only for mapping, but for navigation, guidance and control, etc. So I just wanted to kind of point out that. And I also wanted to point out a couple of other areas where PPRTX is extremely valuable. One is in the area of beyond visual line of sight mapping. PPRTX is really, really a nice solution for doing that kind of mapping because you don't need to. It's kind of much more difficult setting up a control network over those longer flights and baselines that you're working with. So PPRTX works very nicely in that. And it's also very suitable for those areas that may be, say, for example, forested, where it's very hard to kind of set up a control network there. And so it also works quite nicely there. Okay. And I just wanted to kind of end that this whole PPRTX solution, you can find more about it on the Trimble website. It's very flexible, a lot of different ways to consume the correction data from the PPRTX solution. I certainly encourage you to check that out, both on the trimble.com website and on the applanix.com website. There's information there for both of those. So on that, and hopefully we've not lost anybody due to any kind of audio problems or anything like that, we'll open it up to questions. And this morning, Cynthia from our marketing department is with us. And Cynthia, is there any questions that have come through?
Hi, Brad. Yes, we have one question here. What applications can PPRTX be used for?
Yeah, good question. Really, PPRTX, and as I was kind of alluding to at the end of my comments there, it can be used for all different types of mapping projects and all kinds of positioning projects. So it could be manned airborne, where you're actually flying large metric cameras on crewed aircraft that are flying these projects. So it can be used there. Certainly can be used in the unmanned segment. We talked about that, or I guess the uncrewed segment would be the political correct term to be used now. And so it can be used there. We also use it quite extensively in our land applications. So for basically automation of vehicles, etc., it's very applicable in that area too. And furthermore, we use it in our marine applications as well for marine mapping, etc. So really, it is applicable to a wide variety of areas where you're actually where you need positioning data to basically correct your data.
We have another question here. Is it possible to know more on about RTK precision without station reference? I'm not too sure exactly.
I don't know. Is Kurt on the line?
Yeah, I'm here.
Yes, he is.
Hey, Kurt, did you? Yeah, I'm not really clear of that question either. Maybe it came through better.
Sorry, can you repeat the question one more time?
So there's multiple parts. So it says, is it possible to know more to near RTK precision without station reference? So I think they want to know more about RTK without base stations possibly. And then in a single physical base station, baseline errors converge to what level in 30 minutes?
All right, so I
That's
guess
a separate question.
Yeah, those definitely do seem to be separate questions. And since this is kind of relating, I'm assuming based on PPRTX. So PPRTX is a global service, and we are getting those near RTK performance. But this is again using estimations opposed to eliminating air sources. So we're estimating the air sources within the ionosphere and the atmosphere based on our global network of stations. So having said that, this is going to be a estimation process, which is why you're taking that time. And to get to that fixed integer ambiguities resolutions, we have to take some time to estimate this. Because this is a global service, we aren't requiring any other base stations above and beyond our network, our global network from a Trimble standpoint. So there shouldn't be any limitations there. And sorry, can you repeat the second part of the question?
So the second question is, in a single physical base station, baseline errors converges to what level in 30 minutes?
Well, and so with a single base station, again, this also kind of depends on what we're looking at. Are we looking at compute RTX coordinates, or are we looking at just utilizing single base station in RTK mode, like in POSPAC, in which case you're eliminating a lot of the main sources of GPS error by using differential GNSS anyway. So there's not really a convergence there. If you're looking at compute RTX coordinates for a single base station, where you're trying to really just upload that RTX or that Rhinex data to the RTX network to get those refined coordinates. I'd say 30 minutes we're looking at, within the centimeter range, 5 to around the 5 centimeter range.
Thanks, Kurt. We have another question here. How is direct georeferencing superior to RTK and PPK?
Yeah, I can take that one. So basically RTK and PPK have inherent problems that reduce their accuracy, productivity, and efficiency to a certain degree. Many of these problems are revealed upon a detailed analysis of their associated mathematical and scientific principles and calculations. One of the major factors for reduced accuracy of RTK and PPK is the calculation of orientation angles of any of your sensor data. So DG actually measures the orientation angles and any imaging sensor with high accuracy and high frequency. So basically, it really brings in, I guess if you want to kind of summarize it, it really brings in the orientation data. And the orientation data allows us to basically position any of your LiDAR points or your pixels on the ground without having to use ground control points. That orientation data, along with the GNSS data, combined on that collection board that we have, what we call at Applanix, our APX boards, allows for that data to be captured very accurately without ground control points. And so really, that's how direct georeferencing is superior to RTK and PPK, because really it brings in that very precise orientation data that allows us to measure things very, very accurately and put the data on the ground where it's supposed to be.
Great, thanks, Brad. And we have another question here. What sensors can be used in conjunction with the PPRTX service? Yeah,
I can answer that one too. So LiDAR, really any kind of sensors that you typically be flying on your UAV systems today. So LiDAR cameras that could be near infrared cameras or RGB cameras, hyperspectral sensors, multispectral sensors, multi-beam sonar, SAR, all of those kind of sensors can basically consume the PPRTX data.
Perfect. And one last question here. Can you explain in more detail about the compatibility of the service product with UAVs or flight controllers that are available in the market?
Maybe Kurt can take that one.
Yeah, so I hesitate to go too in depth on the different flight controllers because there is some variability there, and I don't really want that. That's not really where we're looking at. We're not looking at utilizing this data to replace or do anything with the flight controllers. So I'll kind of steer clear of that now. If you're looking just for for compatibility with the different UAVs, again, we're not really limited in what kind of UAV platform you're going to be choosing. So I mean, if you want a fixed wing or rotor application, we're pretty flexible in that regards, and we have dynamic models for each, and we can go ahead and mount and utilize on any UAV platform, and then go from there and get that really accurate direct georeferencing data. So there's not really any limitations there. It's kind of more up to the user to decide how they wish to integrate our product and utilize our product going forward.
And we have one more question. So is it possible to have access to learning documentation and more on how to use our products and solutions? So I guess they want to know about our resources. Brad, if you can touch on that.
I can indeed. So just before we wrap up, let me address that. So really, if you're looking to learn more about what we offer and the products we have, there's a number of sources you can go to. So our main website is applanix.com, and that has a lot of great information. There's a specific set of pages on our website dedicated to our UAV solutions. You can find those at products/DG-UAVS, and that has a lot of great information. And also, if you're looking for information on SmartBase, maybe not so much since it's not really available in India yet, but we do have a separate website for that called applanixsmartbase.com. But perhaps the best learning tools we have to date are in our webinar center, and you'll find that on our main website. We have a whole series of webinars on basically everything working from your integrated GNSS, INS board sets to augmentation solutions to working with POSPAC to generate products that you can use for information for decision making and these kind of things. So we have a complete range of webinars there that explain all of this technology. So as I say today, we really just kind of picked out a segment of that technology to talk about, and we'll have more webinars in the future for the India market, and which will then take other aspects of the technology and we'll discuss those for you. So we're just kind of taking these bite-sized chunks of topics and just breaking them down into what they are and how they work and how they bring value to your operations and your UAV missions. So hopefully that answers that questions. If not, you're certainly free to contact any of us. I've got our contact details here. So Sanjeev is Sanjeev_Trahan@trimble.com. Naush's email is here. My email is here as well too. Please feel free to contact us if we may have not answered all of your questions today, and or if you want more information. Any one of us would be happy to help you out and get you the information you have. So I think on that note, I just want to let Naush and Sanjeev, if you have any concluding comments, or Kurt, if you have any comments you want to make at this point, go ahead. Otherwise, we'll just wrap up this webinar for today.
I think I'm good. Thank you.
Good.
Thanks for the presentation. And
thanks.
Okay, great. Well, thanks so much. Thanks so much to our audience for joining us today. We really appreciate that. Hopefully you...
Brad, I'd just like to add one thing to what you said. Totally appreciate everyone being here, taking on the time to be attend the webinar late in the evening. One point that the smart base station, the VRS setup, etc., as Brad rightly mentioned, this is the future for our country. Survey of India is setting up a network of base stations throughout the country. And as per the new geospatial policy, there should be a mandate that these reference stations will be shared. When and how, that's probably being worked out. So let this be a kind of advanced session, and we can come up later once the information of how the government is going to share the network of core stations with the public and with the professional companies carrying out surveys. We can have another session of how it can be leveraged in greater detail. But be aware that this will happen very, very quickly. All these aspects of giving correction to the UAVs will be applicable in India pretty soon. Take it from me.
Awesome.
Thank you.
Awesome. Great. Thanks, Sanjeev. I really appreciate that. That just kind of bringing some further clarity to that. And as I say, so I think on that note, we're going to wrap things up. We kind of planned on going for about 30 minutes. I think we kind of blew past that. But anyways, I do want to thank everybody for attending. And please look forward to our next webinar for India. It'll be announced soon. We're just in the final phases of getting that together for you. And I look forward to being with you again in the future. Again, thanks everyone. Thanks to our team. Thanks for all who attended. I appreciate it. Bye-bye.